I'm still on the Birla Carbon stand. I'm here with Cédric de Villepin from Nanocyl. Hello, Cédric.
Hello, very pleased to be here with you.
Now, you make a very exciting material of which we have a 3D printed model here, which is multi-wall carbon nanotubes. Can you tell us a little bit more about it and what are the typical applications in plastic?
So, carbon nanotube is an extraordinary material in terms of intrinsic properties. So we are talking a material more conductive than copper, 4 times more mechanically resistant than steel at a quarter of the specific weight, and also more thermally conductive than diamond, the most thermally conductive natural material known today. So we are talking extraordinary material at the particle level. Then we are incorporating this carbon nanotube into different kind of matrix to increase their properties, typically providing electrical conductivity with a very low amount of filler is one of the main things carbon nanotube do today.
And you're doing this in a masterbatch, in a pre-dispersion, correct?
Yes, typically. So we provide a carbon nanotube under powder form. Some customers prefer to use it this way, but we also make it available under pre-dispersed masterbatch form for customers that would not be equipped to handle directly powders or to disperse powders.
Just out of curiosity, a standard carbon black masterbatch, maybe with a Raven carbon black, is up to 50%, maybe 55% is the ceiling. What kind of loading do you have in a multi-wall carbon nanotube masterbatch or pre-dispersion?
So we are typically speaking about loading between 10 and 20 to 25% of carbon nanotube. There is typically with these range of loading that we get the best dispersion of the material, and that we also are able to preserve base properties of the base resin. When you have a too high loading, you start to have high shear force that can damage the resin and lose some properties. So typically, I would say between 10 and 20% weight percent of carbon nanotube is a sweet spot for the optimum properties.
What is the kind of supply chain to market for these materials? Because in carbon black we have standards, we have the known grade range of carbon blacks. I guess with multi-wall nanotubes it's a little bit more difficult. And how is this made to order, or how do you? What is the supply chain like?
There will be different types of carbon nanotubes. In our case, we are mainly concentrating on multi-wall carbon nanotube and mainly the NC7000. That's our main grade, is the most successful in a large type of application. We are mainly concentrating on this grade, but besides this grade, there are some specific grades that will be developed for different types of applications, such as battery application, for example.
And the aspect ratio is quite extreme, right? You told me, what is the diameter again?
So typical diameter of the material here will be in the range of 10 nanometer in diameter. So that's about 10 atoms with a length in a few micrometers. So we are talking an aspect ratio of more than 1,000. To give a number, if you would take 1 gram of carbon nanotubes, these carbon nanotubes, you put them one after the other, with 1 gram you would go 160 times around the planet Earth.
Whoa.
With 1 gram. So we're talking a pretty long aspect ratio material, and this is one of the reasons why it's so effective to provide electrical conductivity, for example, because with such a material you can connect very easily through a material. You make a network through the material.
You have much lower threshold addition rate, right?
Exactly. When you compare the application where you would use carbon nanotube for electrical conductivity, for example, you would talk much lower loading in terms of additive working from the carbon nanotube, which means that you are able whether to reach higher level of electrical conductivity or that you can get better mechanical properties out of your material because you reduce significantly the amount of filler, meaning that impact strengths or elongation strengths will be much better preserved.
But you're still black color, right? Or or you put as little that it's not black anymore.
Yes, yeah. Well, carbon-based material are black. Black is beautiful, isn't it? But still, there is a little further aspect here is as the loading is much lower. There are cases where we can reduce the darkness of the material, but we would be talking about applications where the loading of carbon nanotube can really stay on the low side, and as well typically where you would have a very small thickness of the material. When you add up the layers, obviously you're getting more darkening effects.
Just out of interest, Cedric, I mean, where do you position multi-wall carbon nanotubes for conductivity along with graphenes and maybe highly structured furnace carbon blacks and single-wall nanotubes? Where's the advantage of multi-wall nanotubes from Nanocyl?
So, well, basically you have this type of pyramid, which shows, let's say, the complexity of the material, the ability to get a higher range properties. Multi-wall carbon nanotube will be at the top of this pyramid compared to, let's say, standard conductive material, highly structured carbon black, graphenes, and carbon nanotube will come on top. Meaning that you would really need the lowest amount of carbon nanotube in order to reach this electrical conductivity.
Thank you very much. Anything else? Any message to K-Fair visitors?
So we are here at the K show with the whole 8A J29 together with Nanocyl, of course, part of Birla Carbon on the Birla Carbon booth. So we'll be very happy to meet you here to discuss further what carbon nanotube can bring to you.
Thank you very much, Cedric. Have a great fair.
You're welcome. Thank you.